Well, today's Tuesday. It's a cold one today, but I'm going in the shop and I have to use the Boblov W1 simply because, I can use the Kodak Z1, but I can't get close enough for it. And both of my JVCs are being charged. So I figured we'll grab the Boblov. Because the Model 30 and the Model 100 are both charging. The batteries just sit and they just go dead or get down real low. So I wasn't going to make a video, and it's cold in here. Colder today than it was yesterday, even though I got this little heater on. I'm just throwing this video together, nothing fancy. I don't have a good way to hold the Boblov. The stand, the little bracket I made, that's out in the car. I keep that out in the car. So what I'm going to just probably do is hand hold this and show you. It's been suggested, and of course I'm aware of this, to just make a power supply using a bridge rectifier. But as far as I know, you can't use a bridge rectifier unless it's on a transformer. You know, the circuits I have seen all run on, you got to have a transformer in order to use a bridge rectifier. But there's nothing wrong with using a single 1N4007. This happens to be a bridge that I made up last year for another project I was working on. I still got my Rube Goldberg stuff all sitting here. And it's also been suggested that I should just go and buy the batteries. Yeah, that's fine, but you got to remember, you know, I'm going to spend $10 on 7 batteries. They're $1.25 each at the Dollar Tree. There's no more dollar. And if the IF cans are bad in this thing, I wasted that money on all those batteries. So that's why I haven't done that. I'm very well aware of making them out of 9-volt batteries, but I don't want to invest in the batteries at this time because I want to try this out with the power supply. I'm going to attempt to build a power supply maybe on this video, but I'm not going to actually do the construction on the video. What I am going to do is to show it as I'm, you know, I do some and then I'll show you some of what I'm doing. So what I'm planning on doing, it's been suggested to go through the Variac. Yes, I've thought of all these things. As a matter of fact, my power supply that I want to make, if I get the right case for it, is going to be, like I say, a brute force power supply. It's not going to be regulated or anything. And I do have a Variac, and the Variac is going to be built into the power supply and simply turn the primary voltage up and down, and that'll adjust my output voltage, and I'll have a transformer that will put out enough voltage so I can have 450 volts for radios. But right now, what I have to do is I'll simply use my isolation transformer, which I do in the Variac, plug in a cord into here. Like I say, the Variac varies the isolation. I think that's the way I got it hooked up. I don't recall it. Yeah, here's the cord for the Variac, okay? It goes into the isolation transformer. So the isolation transformer is connected directly to the line. Okay, it's plugged in. Okay, so it feeds, the output of the isolation transformer feeds this Variac, and then I'll plug my cord into here, adjust this to under 115 volts or whatever we get. Yeah, we don't get much voltage. We're lucky we get 115. It's been a lot lower than that. That's just the way it is around here. And in the house too. It's not out here only. So I can control that, but as far as I know, unless I'm wrong, and I'm wrong a lot, there is no way you can use a bridge rectifier unless you're using a transformer, and in which case you connect your bridge from one leg of the transformer to the other, and then take off your DC, your plus, your minus, and your plus on the other two legs. That I well understand. However, there's no reason why I can't use a single 1N4007 feeding the filter capacitor or two and adjusting it. And that's essentially what my power supply is going to be. I know I'm talking a lot, but I want to explain something because it's a lot easier, like I say, than to me to type. I've been answering some comments, but I can't do this. It's very difficult for me to do, as I said. But several of you had mentioned, why don't you just make a power supply using a bridge rectifier? But like I said, you got to have a transformer to use a bridge rectifier, and that's what I will do in my original design. This here is a power transformer that's all marked out, but this is designed for high voltage, the 450 volt power supply, and that's what I will use. And the variac will vary the primary of this transformer, so I can adjust my output. But there's going to be no regulation, so if the radio draws a current, you just turn too much current, pulls the voltage down, you'll simply turn your variac up. And of course, I want to have a meter on the output, monitoring the voltage. So these things will have to be adjusted. Like if you get a radio that's drawing a lot of current, you've got it set for 90 volts, let's say, and it drops to 80. Well, simple as that, you just crank up the variac on it. So that's a simple power supply. However, this transformer the voltage could be turned down low enough, even though you're putting out 350 volts per leg or whatever. I don't remember what the output is. I think it's 325 or 350 on each side of the center tap of the output of this transformer. You could turn it down low enough so you'll get your 90 volts or your 68 volts out. So that's basically what my power supply is going to be. What I'm going to do is simply line connect this. Well, it'll be going through a variac and an isolation transformer. I'm going to line connect this, and I've got a cord up here. This yellow job right here, which is the cord I use. And I'll plug that into the isolation transformer output, and variac output, I should say. And I'll put the rectifier on the black lead, which is the hot side. Feed it into a couple of capacitors and adjust the variac for the output. Alright, I'm not a good artist at all. I'm very, very bad at drawing. I'm using the Bob-Lob on this, and I think it'll show up. Simple, very simple, basic, non-complicated power supply. Your hot, your neutral, your plug, which is into the variac, which is going to an isolation transformer. Okay? So you're feeding in 115 volts. In our case, it's 115. Okay? You're coming out here to a 1N4007 diode. I hope you can see that. I'm the bad draw artist. And I'm showing one filter cap here, but there's going to be both of these in parallel. There's my 1N4007. The 1N4007s I got a whole package of them, like 100 of them. I got them from Jewett City quite a few years back. They came in a pack, and you can hardly read the bands on them, so you really can't tell. I do everything by experimentation, so I simply put my line here and put a meter on here, and if it reads negative out of here, then I just got to reverse the diode. That's no problem. I've done that all my life. But the banded side is the part that is positive. In other words, your DC output is at the band. So your band is at this end. Okay, so your positive is here. So you're going to have, if you plug this directly into your line and it's rectified, the voltage is going to be stepped up to the capacitor. In this case, 680 microfarads at 100 volts. Now, what I think I will do in this case is I will put in 150 or 160 volt cap, probably a 47 microfarad or somewhere around that area on the output of this here, okay? And then on the output, here's your plus and here's your minus. You're looking at this area here. This is the capacitor will be over here. That this capacitor is going to be over here. Okay, so this is the output, which is probably going to be, I don't know what it is. I have to put a meter on it to find out what it will read. I don't do math, so probably you're going to get about 120, 25 volts maybe out of this unloaded. So in that case, we put a resistor here, and again we experiment. We don't use math. So this is how it's going to be. So you got a resistor here. Sorry about the artist. I'm not an artist. So at that point, when this voltage is reduced, the current reduced to this resistor, which I got to experiment with, I have no idea what it's going to be. Then we can vary the variac here. It's very important that we do that before we connect up these here. Okay? So we turn the variac down until it gets to about 60, 65 volts or so, to be safe. Then put these across it. Make sure that the voltage don't go too high. Okay? These are rated for 100 volts. So we keep the variac down so we don't get 120 volts or whatever you normally would get out of here. You turn it down to 60 or 80 volts. Use, at this point, as I said, probably a 47 microfarad, 150 volt, just in case this thing gets accidentally kicked up. Because if I put these on there and it goes over 100 volts, I've ruined two good caps. So we do that, and then we put a resistor in here, and then we put these capacitors across here, and then make sure that the capacitors are fully charged, and then we put our radio on. Now, before I do any of this here part, we will make up this circuit using the 150 volt 47 microfarad or whatever I got, the largest one I got, to put across here, and adjust the voltage down. We start low anyways, until we got about 60 to 65 volts across here, unloaded. When it's a stable 60, 65 volts, we establish that. At that point, we will turn this up until it's 68 volts. Then we can add a resistor to the positive. And what we'll do then is we'll try out the radio before we add the extra caps here. So that's my plan anyways. Everything I do is strictly by experimentation. I've always done it that way. I always start out like a resistor. I start out very high. I don't get much out of it. Then I go down to a lower value until it comes out to where I want it to. I'm very limited on high wattage resistors. Very, very limited. So all my resistors are mostly half watt, quarter watt, a few 1 watts, and a few 2 watts. So I'm very, very limited, and I'm estimating probably need 5 watts in here. So here you don't need the resistor, but it might be good to put one in here. I don't know. Let me experiment with these. Alright, this is just a quick setup right now. Hopefully you'll be able to see that. We got the negative of the meter. There's we're plugged in here. This is off. The isolation transformer is on. No, it isn't either. Now it's on. Okay, but this is off, and the voltage is all the way down, and we're plugged into the output of the variac, which is also the isolation transformer. Okay, so what we got now is I can't read the band on that, because the bands are all like rubbed off, and out of that package you can get several of them you can read the bands on. So I checked them all with the diode test of my meter. And somebody had suggested you can measure current with your digital multimeter. I'm very well aware of that, but what you can't, some people don't get the point that my ICO 950 will not deliver the current needed, and the radio draws too much off of it, so you can't measure the current. You need a power supply that'll give you the current, and then you can measure it. So, okay, so here is a old 40 microfarad, 160 volt Sprague Atom. It tests good. I got the negatives all connected up, and in which case, the negatives here were feeding in the line. That's why I say you can't use, to my knowledge, you can't use a bridge rectifier on a line-connected power supply, even though it's going to an isolation transformer. To my knowledge, you can't. Every bridge rectifier circuit I have seen has a transformer feeding the bridge. Okay, but anyways, right now I just got the meter plugged. You're going to trace my wires around here, ring around the rosy to the positive lead. Okay, so what I'm going to do now is to turn the variac on. The variac is all the way down right now, and if we got the right polarity, we will be reading a positive here. Right now, it's reading AC, and it shouldn't be, unless the diode's not shorted. I just checked it with the diode check. So, now that is weird. I'm 26 volts, but I'm reading AC. I thought this meter would automatically change, but maybe not. Well, I can't feed AC into it. You know, I really need a schematic to find out how to do this. But I'm wondering. I said, mate, it's a simple rectifier. Rectifies the AC coming in, and it's only connected to the meter right now. I'm not going to put this on there. It's reading AC. Let me, there's no capacitor, so I can turn this up higher. We got 61 volts. Well, it's 79 volts. Still reading AC. 42 volts AC. go on the other side of the rectifier. $71.9 volts AC. It's pretty close. 73 here. All right. Well, it's probably a pulsating. That shouldn't be, though. I'll be right back. I'm going to get my my Fluke 73. That's your good old reliable meter, because you can set that to AC or DC. Somehow I don't trust that new meter. I don't think that's AC. I don't think so. I'll be right back. Okay. All right. We got this set for AC on the Fluke 73. All right. So I want to see what that will read. 50 volts AC. 44.4 volts AC. Now you see, that's probably the ripple because there's no filter on that. Let's go to DC. All right, we're reversed though. We're negative. All right, so you can't go by this. Unless there's a setting, I thought this was auto, auto ranging. I don't mean increasing voltage, but I mean like if you put it on AC, it always did before, but that's why I love my Fluke 73. I trust that more than anything else. All right, so we're reading negative out of here. So we can't put that in there, that's for sure. Let me, I don't think this will stand up. I'm using a Boblov W1. Let's turn this off, put the voltage down. Take this diode out and reverse it. Let's just see. All right, this is the positive when my hand is on. No. I have it reversed. The band is at the other end. Band is very, 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 very hard to read. Very hard. That's the problem when you get surplus stuff like that. That's probably why. But they're all good diodes. They all test good. All right, now we're reading 1.5 volts DC. Why, I don't know. We're not on. $50 volts. We're properly, and we're getting 21.4 volts out. So we're connected good there. Now, we got the capacitor on. We're getting 65 volts in the capacitors across it. So we actually have right now 60. Oh, it's not on there good. Let me. I'll be right back. All right. We got 31 volts. That's because the capacitor is holding a charge. The variac is off. We did not change the voltage going in. We got 50 volts going in. I just turned it on. And we got 65.3 volts coming out. So we're almost there. So we got 52 going in, 69 coming out, 51 going in, 67. All right, we're not going to split hairs here. 67.3, 68.8. That's fine. That's what we're getting out of here. So theoretically, this radio would work if I connect it directly across here, but we don't know what the current limitation is. Well, actually, we do. It's limited by a 1 amp diode right here. So if the radio draws more than 1 amp off the B+, we're in trouble. So what you really need is a limiting resistor on the output. And the output is going to be this filter capacitor here. So actually, I'm safe removing this and putting these two in. However, putting that much capacity, 268, 680 microfarad, two of these. Don't know if it's upside down or not. Could kick that voltage way up there. So this is only 40 microfarads, but that's what I'm getting. So I think we're going to do, we're going to put a series resistor in here, and then we're going to take one of these capacitors, not two, and put it on the output, proper polarity of course, so there'll be a surge resistor between the plus of this and the plus of the output. So this will be the output cap. We'll do that off camera, and I'll be back. Alright, here is what I did. It's a Rube Goldberg. Quite a Rube Goldberg. I think this is a 1 watt. This is a 1,000 ohm resistor. I kind of like the 1,000. Judging from my experience with power supplies, they're usually between 1 and 2,000 ohms. Between a filter cap to another. So what we've got now is the electrolytic, the 40 microfarad, 150 volt, still connected this to the diode. Okay. We've taken our meter, the voltmeter, and output on this 680 microfarad. In other words, we're measuring the voltage from this now, and of course the common ground over here, which is the neutral. All right. And the meter is connected here. So when we flip this variac on, the 52 volts, we're getting the same voltage, which is good. So now I can take the radio. I got enough clip leads here, I think. I got one for the negative. It's still a rat's nest over here. But hey, every workbench I've ever had was a rat's nest. You know, if you don't have a rat's nest on your bench, that means you're not doing anything. So we got to take the radio now, and we make sure we put the radio connected between the negative and the positive right here. So we're going to set it up. Again, we are going to try to get that D battery in here. We're 69 volts. We got nothing to worry about there. We'll shut that off for now. We'll save the battery and the meter. One day last year, I left this thing on all night, and the battery was dead. 9-volt batteries, you can't get the alkaline no more at Dollar Tree, at least not around here. They're just the ordinary, I don't know where it is now, regular ones, heavy duty or whatever. So you can't get alkaline. So if you ever made a power pack for this and bought alkalines, it'd probably be $50 in batteries. So anyways, let me get this connected up. Again, I'm sorry for being handheld here, but I figured this is the quickest camera I can grab because as you can see, the blinking lights are happily charging both of my JVCs, the Model 30 and the Model 100. The Model 30 is, it does 720p, so you notice that last video was not a 1080p video because this is the higher quality JVC, the Model 100. This is the Model 30. But it does good even at 720p. I'm very happy with both of those cameras. They work out very well. And I did not get any distortion on the audio from it. Okay, so enough flapping. I got to get in here and get this radio up here, so I'm going to have to, this is off. We're keeping the voltage the same right now. And when I connect the radio up, I want to find out what it's drawing. And at that time, I can put a milliamp meter in and see what it's drawing. What's going to happen most likely is this 1 watt resistor, and I don't think it's more than 1 watt, is probably going to run very, very hot. That'll be determined by the current draw of the radio. I'll be back. Make sure it's recording. Okay, we're on DC. I just turned the meter on DC. We got the radio connected. We got it more Rube Goldberg wiring here. Alright, the radio, if you follow the wires, goes to the positive of the 680 microfarad, which is which goes to a resistor and back to the main filter output. So we're going to flip this on. We got 68 volts coming out, 69. That's all right. There's a fluctuation there. And we're going to open up the radio. This is not easy to open. This is very, very hard to open. But we want to see, I'm going to try to hold this camera steady. Look at the meter. It still says 69. Don't seem to make any difference. It was drawing current before. This is not getting warm. We got 52 volts going in. We got 69 coming out, but why don't we have anything? Maybe the battery is loose again? Gotta watch out we don't short this thing out here. It's not easy working one-handed. I don't know how these guys can do it. Don't seem to be doing anything now. And I do have the battery in correctly. It was doing better with that other supply there that I was using. It's not pulling down at all. I haven't done anything to it. And we got the positive hooked up correctly. We're not reverse polarited. Well, I gotta shut this off. I'm gonna change batteries here. That damn wire came off. I didn't even see that. It was hanging down on my lap. I changed the lead. I thought maybe I had some bad clip leads because these things go bad very easily. But it didn't make any difference. So let's go and put this back on the ground where it belongs. Now it's 57 volts. Okay. Now I'm holding the power switch in, which would shut off the radio. I'm letting it out now. There's the power switch right there. 57. Well, don't think 57 will quite do it. No, dead silence. 59. Well, we don't want to burn this resistor up. That's lukewarm. So that's why you use a variac on the primary when I make the power supply, so you can crank it up. So let's crank it up. All right, there we are on 69. Let me put this camera, hopefully it doesn't fall over, and I can use both hands on the radio. Possibility the speaker could be bad. This is why I don't want to invest in anything in the radio. Naturally, it could be a tube or something, but we're not going to be getting into that until the warm weather stays here. It's still cold up here. So I'm doing 69 volts. The resistor just barely warm. I'm feeding 59 volts AC. It was 53, so that's not too bad. Now the speaker's good because I can hear a little static in it. So the question is, what's the D cell doing? We don't know. And yes, there could be some bad tubes, as was suggested. I did not expect this to work anyways. So, gotta hunt down my positive lead here for the other meter. Seem to have lost it. Oh, here it is. What a Rube Goldberg arrangement I got here. So we'll put this on. I want to see what the... Oh, nice. The camera fell over. All right. I want to see what the A battery is doing. It could be very low in voltage. Remember, these are not alkalines. .3 volts. The A battery is 1.3 volts. All right, we'll turn that off. .64 volts. It's gone down to 64 volts, so we'll push it back up to 68, and we're feeding in 62 now. So alright, so we probably got some bad tubes. Okay, so what are we drawing for current on this? Well, I have to get in here with some meters, with a meter. Pretty awkward. We'll do that at another time. We got work to do on this. I didn't expect it to work. However, you pull the A battery out, and it's 79 volts now, 80, with the A battery out. So this is 1.3 volts. It dropped to 1.3. It was only reading 1.56 and thereof. So, all right. So we'll turn this off. It's a little cold up here. And we'll shut this down, turn the variac off, turn the main line off. Leave the mess here for now. Alright, so we gave it a run. It's dead silence. I can hear a faint static in the speaker when I push this button. This is the power button right here. It goes on when you open the door. So what I did yesterday is I took this knob off and I put some 3-in-1 oil in the ball bearings here, so it turns a lot easier now. Still a little stiff, but not too bad. I think, I don't know if there was supposed to be any felt washer in there, because you got the writing here. I always worry about it scraping and wearing it off, but maybe it'll be okay. So, looks good. Oh. I don't know how these guys can work one-handed. Man. All right. Anyways, that's it for today. A little bit of entertainment for you, maybe, for those of you who like this stuff. But that's what I'm going to do. We're off there. We let the batteries charge. That's where we're at. I don't think it's drawing all that much current. I could measure it, but I got such a rat's nest in here. And the digital meters, they'll both read current, but I've got another one back there that I got at the ham auction that also measures current. A lot of my meters will read current. But I think when I get this thing going, I'm going to invest probably about $2 or $3 for one D-cell alkaline. And then I'll make up a battery pack. I've never done it before, so I don't know if I can get it to fit in the radio. But there again, this is a spring project. I mean, if we get a week of real good weather, yeah, I'll go into it. But I don't want to start this and then have it sidelined until 2 or 3 more months from now. You know, I don't want to do that. But this is how I plan on making a power supply. Simply a brute force. And if I need any regulation, these are bleeder resistors. You remember the old Dumont? You probably wouldn't know. It's probably before most of you guys' time. I had a Dumont 103 doghouse. I kicked myself for getting rid of it. It was well over 100 pounds. 12-inch. Had an FM radio in it. FM tuner. It was a Mallory tuner. In other words, a continuous tuner made by Mallory Corporation, I believe. And in the B+, it used a bunch of high wattage bleeder resistors, and that's how they got their voltage. I think it used 2 5U4s. It was a beast. That's basically how I'm going to do it. If I want to keep it, you know, just get a string of resistors and have it across the whole output, and you can tap off of it to get the voltage you need, and have the variac to fine-tune it. Might get a little better regulation than that, you know? Because I like vacuum tube stuff, so I have never built anything. I built preamps for CBs out of, using 12AX7, 12AU7 tubes, stuff like that, but I always built it using a schematic. It's stuff like that. So this is basically, you don't need a full wave bridge and then have to invest in it. Well, when I make the power supply, naturally it's going to have a transformer in it. And it'll have much bigger, higher voltage capacitors, and it'd be much better. And I may use solid-state diodes, which I think would probably be the best way to do it. We don't need to use a vacuum tube rectifier. They'll generate a lot of unnecessary heat. Okay, that's it, folks. So I just wanted to make this video to let some of you guys know that what's happening here, and that the fact of the matter is, I'm very well aware of the things that you had suggested. You know, you can use your digital multimeter to measure the current, but in order to measure the current, you have to have a power supply that's going to deliver the current in the first place to keep it at 68 volts going in the radio when the radio is being used. So, this thing is drawing current, and it is not because the electrolytic in here is charging up. I proved that in the first video. Feeding in the voltage, it charged up the capacitor to a certain point, 68 volts, and it stopped. But when I connected the A battery to 1.5 volt, then the radio drew a lot of current and pulled the power supply down. So it tells me that the tubes are working, but not all of them, because they're in parallel. There could be 1 or 2 bad tubes in here, but what is working in here is drawing current. All right, enough of this. I got to get out of here. It's a little cold, so I'm going to throw this video together. It's 3 o'clock in the afternoon. Time to say goodbye on this video. Thanks for watching. Take care.